Hey everyone, and welcome to my channel. So I haven't posted in a long time, but that's because I was working on something super cool, and I'm going to show that to you guys today. So what I created was, I tried to implement a genetic algorithm, which is kind of like, I'll go into it, of the past few weeks, and then what it does is tries to play Pong to the best of its ability, given given the information that it has. So let me start sharing my screen, and then you guys can see. So basically, this is my code for the machine learning. Oh, that's the wrong one. This is the code for my machine learning, and this is what creates the weights and gives it to my the paddle in the Pong thing, right? So let me first explain what weight is. So basically, let's say you had a person, right? And this person had left their tap on at home and they're driving to work. So if you're a normal person, you would know that turning off the tap is more important than getting to work because you don't want to flood your house, right? So let's say going to work would have a weight of 100, while going home and turning off the tap has a weight of 300. So you would go home and turn off the tap because the weight is higher, right? So that's basically what's going on in this particular code. I have, okay, well, that's the wrong file. So I have all the weights over here. It's commented out because I want to show you how it looks without the weights, which is just random. So over here, so you can see that these have different numbers. They correspond to different things on the in the particular in the game, basically. So some of it would be the position of the ball, and then it's multiplied by a certain weight in order to see where it should go, and then the position of the paddle, like the thing that hits the ball, and that has a certain weight, and then it modifies it in order to spit out a negative or a positive value to see whether the bot should go up or down. So over here you can see that in action. Okay, so this is the input data I was talking about. Okay, you can't see me pointing. So that's the position of the ball, the x position. So if you, okay, so it's like that. Like that's the Cartesian plane, and then over here would be the x-axis, and up and down would be the y-axis. So that's the position of the ball, and that's the velocity of the ball, the x velocity, so like the direction it's going, basically, and the y velocity, and then we have the position y of the other paddle. So, and then you have the complete calculation here, which is used in order to see whether it goes up or down. So over here, it has the complete calculations, and then it adds up the input variable. So from here, multiplied by the weights, which I showed you earlier, which I showed you earlier, in order to create a number which impacts how the algorithm, where the algorithm decides to go under a particular circumstance. Okay, so, and then I'm going to go over something called, well, actually, no, not something called, it is called the fitness algorithm. This is actually, like, probably the thing I'm most proud of because it took a long time to do, but I think it works pretty well. So, let me find this thing. 1 second. Oh, I think it's over there. You know what? Let me search it. Fitness. Fitness. No, no. Is it this one? No, it's not that one. What the? Oh, there it is. Okay. Okay, so basically what it does is, depending on how many hits the bot gets, it adds a certain amount of points. Over here I put 1,000. Not really sure why I chose that number, but I chose that number because, I don't know, it just felt right. And then we have the distance from on failure, so like how far away is the ball when the bot fails, basically. And then it adds up, spits out a value, and then depending on that value, it will assign it a certain fitness, and then if your fitness is higher, then you're better than other bots, so you get placed higher. And as you can see here, this monster of a bot got 802 hits on the ball, which is pretty crazy. And that was only the first epoch, so if I train it for longer, then it would probably do a lot better. An epoch is basically like a one evolution, so like, yeah, like one generation kind of. So I'll go over it a bit. So basically this is what the bot looks like when I do not have any of the weights implemented. So you can see it's like not really knowing where it's supposed to go. It's just flying all over the place, and it just doesn't do anything. And if we luck out, it'll hit the ball. But if we don't, then it doesn't hit the ball, and then just goes on to the next weights. Oh, and then something just hit the ball. Okay, anyways, I'm gonna show you guys what it looks like with the weights implemented. Okay, so these are also still random, but they're like building upon the, oh wait, what the? They're building upon, okay, I think my screenshot just cut out. But they're building upon previous generations and creating new weights based on them. So let's watch these play too. Okay, I don't know what happened. Oh, I think I turned that off. Okay, there we go. Okay, so basically this is what it looks like when the weights are implemented. So it's still really not great, but that's because it like multiplies it by a random amount. Oh wait, I forgot to do something. That is why. Because I forgot to change the epoch, which makes it use the current value. So as you can see, the bot is doing a lot better here. It's still not great, obviously, because it is still random to a pretty large degree. So you have the previous weights, and then it changes it by a certain amount to see if that weight is better than the previous weight. And then if it is, then it makes it onto the list, and then it makes it to the next generation. And if it isn't, then it just gets tossed out. So you can see like the bots here are doing a lot better than when it was just completely random, and they are hitting it pretty often actually. So that's basically the magic of this algorithm and machine learning algorithms in general, is that you don't really have to like hard code anything in. Like the bot just like finds out what the best way to do it is, and it does it. So obviously my code right now is pretty bad. I could optimize it in a lot of ways. For example, I could use some parallel processing perhaps, so I can run like multiple of these games at once, because like right now it's, okay, let me show. Right now it's using like, I don't know, where is Godot? Godot is using like 0% of my CPU, so obviously it has a lot more processing power to offer. So if I were able to run this like 100 times, it would be like 100 times faster, which is obviously something I want, because I don't want to be like waiting for this for like a year. And also something that showed up really often was the bots would kind of cheat the game, and they would just like find a spot where they could like exploit this paddle, because that paddle just follows the Y position of the ball, right? It could exploit that thing by just like going down here and then hitting it at a certain point on the paddle in order to return it back to the same position. And I'm pretty sure that is how it got a fitness score of 802,401. So yeah, we're gonna try and avoid that in the future. I can perhaps implement it with something that rewards it for moving around more, but I'm not sure. I'm gonna try and iron out the curves in the future, but right now I think this is pretty cool, and it's something like super proud of. So I might like show you guys how I made this in the future, and like go more in depth if anybody would like that. So yeah, thanks for watching everyone, and I will be back soon with another video showing how, oh wait, this one's actually pretty good. Okay, never mind. But I'll create another video in the future showing the progression of this thing, and let's see how much better it can get. Okay, thanks for watching, and I'll see you next time. Thank you.